So how do you get your amplitude? And I'm looking for like one of these letters that's in here. A. And it is the absolute value of A. It's a distance from a center line. And so a distance cannot be negative. All right, period is 2 pi over B. Good. Now, again, we're only doing sine and cosine here, so it's 2 pi over B. But do you remember what's different for tangent and cotangent? It's just 1 pi over B. Again, just bringing that up. All right. Vertical translation is which one of these? D. So we go up or down. Now your range. Let's draw a little center line here. Your center line is going to be that D value, however much you moved up or down. Here's your wave. And A is the distance that you get from that center line. So how could you get this minimum, this low point? Go ahead. It'd be D minus A. So D minus A is that low number, your minimum. And then this maximum be D plus A. Good job. And I just always draw a little picture. I'm a visual person. I like to see it. All right, that's a review of what we've done so far. I didn't put phase shift on there, but which letter gives you your phase shift? C. And remember, that's kind of backwards, or your left and right. So a signal buoy, which I just think is like the best word, buoy. Signal buoy in the Chesapeake Bay bobs up and down. Do you understand what a buoy is, though? Like you've been to the ocean, those things that bob up and down and measure like the heights of the waves and things. All right. Of this transmitter in feet. Now, when you do word problems, you need your units. So that's feet. Above sea level is modeled by this function, and time is in seconds. So you're going to need some seconds and some feet in your answers here. The height varies between 1 foot and 9 foot. So when I draw my little picture of my wave, your low value, your minimum is going to be 1, and your high point is going to be 9. So that's the information that they're giving us. What is the period of the function? And then what does it mean in context? Okay, you're going to do 2 pi over what part of this equation? It's 2 pi over, what are we pulling out of that? The 4 pi over 7. That looks like a disaster, I understand. When you divide by a fraction, you multiply by the reciprocal. Okay, so it's going to be 2 pi times 7 over 4 pi. You're just going to flip that. If it helps you, put the 2 pi over 1. If you don't need to do that, then fine, but a lot of times that helps people. What conveniently is going to cancel out there? Yeah, pi's cancel, which is good. And you're just going to multiply and divide, all right? 2 times 7, 14 divided by 4, so 7 over 2. Does anyone know what that is as a decimal? It'd be 3.5. I'm going to write it as 3.5. Now we're going to write what it means, and listen carefully to me because this is the answer. It's a definition of what the period means, and I can't change a definition. So when you take your test, this is the answer. Your sentence is going to be, it takes, and then you take whatever number you got. It takes 3.5, what? I need some units. Seconds to complete one cycle. That's what the period is one cycle. So when you take your test, it's going to be a different problem. So it might be, it takes 7 years to complete one cycle. Do you get what I'm saying? Like that's the answer though. The number and the units will change based on what the problem's about, but that's the definition of what the period is. So you cannot change that. Good. No, you could write 7 halves. I changed it to a decimal just because we don't usually talk like that. You would say 3.5 seconds. I don't think anybody would say 7 halves seconds. That's why I did that, but it's the same number, so it doesn't matter. Right? But that's the answer. I can't change it because it's a definition. All right, what is the value of A? Let's draw a little picture. Figure out where our center line is going to be. How much did this graph shift up or down? That's your D value or your vertical translation. 5. So 5 feet is our center there. And this buoy is going up and down on the waves. What did they say our minimum was? 1, good. And our maximum is 9. So this question is asking, what is the value of A? how far are you getting from that center line? A would have to be how much? 4. Good job. So you use what they tell you to figure out what you're missing. But it's the same thing we've done before. It's just now there's a story associated with it. All right. Let's try another one. In an industrial city, I don't know why I put industrial there. In a city, with buildings and cars and stuff, the amount of pollution in the air becomes greater during the work week when the factories are all operating and lessens over the weekend. Does that make sense? You'd have more pollution when everybody's there and everything's running, and then less when everybody's like home and on vacation. All right. The percentage of pollutants in the air is given by this function. Notice that negative out front. That's going to be important later. Time is measured in days after midnight on Saturday night. That's where we're starting, is midnight on Saturday. And then your output is, percentage of pollutants. So a percentage is our output there. So you have days and you have percentage of junk in the air. So what is the period of the function and what does it mean? You're going to put 2 pi over what part of this equation? You have to pull out the correct part. Pi over 3. Good job. So same thing, when you divide by a fraction, you're going to multiply by the reciprocal. So just flip it over. And again, if it helps you to put the 2 pi over 1, then you can do that. If not, then, fine, it's up to you. Again, pi is going to cancel. So 6, and then we're going to write a sentence. And it's going to be the exact same sentence as this one. You're just going to use the information from this problem. So it's going to be, it takes what?
6 days.
6 days to complete 1 cycle. Now, let me talk for just a second before we go on to the next one. A week is not 6 days. A week is how many days? 7. I tried to create this problem so that it would work for 7 days, and the fractions ended up absolutely horrible. And I was like, I am not trying to torture my students. So for the purposes of this problem, since 6 is an even number, can we just pretend that a week is 6 days? What day do you want to get rid of? When there are no more Wednesdays, okay? For the purposes of this problem, I tried to make it with a 7, and breaking it by 7s was not, I tried to make it work. It was horrible. So can we just pretend there's no more Wednesdays?
Yeah.
Awesome. Okay. What is the maximum and minimum amount of pollutants in the air? All right, let's draw a little picture. Where is our center line? 30. Good job. How'd she get 30? Because I think everyone was laughing that I said get rid of Wednesdays and kind of missed that. Do you understand where the 30 came from? It's right there. Okay. Now, do you see how this wave, I drew it going up and then going down? This one is going to go down and then up. Why is that? Because of the negative. That's why I said that's going to be important. Okay. Now, how far do we get from the center line? 12. Do you all see that there? I realize it's a negative 12. That's what made us go down instead of up. But 12 is your amplitude. So you have to take 30 minus 12 to get this minimum. So what is our minimum going to be? So 18%. So 18% pollutants in the air. And then your maximum, you're going to start at that middle line 30 and add 12. So 42%. Cool. All right, when do the maximum and minimum percentages happen? We're going to make our little table. You can put X, Y if you want, but it's technically T for time and P for pollutants, which is actually kind of funny that it's TP, but you can put X, Y if you want. It really doesn't matter. The letter doesn't matter. You have done this. That's my pep talk. You have done this. You did it on your quiz. We did it in every set of notes. It's just now there's a story attached. You start with your phase shift. Conveniently, what got added or subtracted in here? Nothing. Okay, you did not add or subtract anything. It didn't shift left or right. So that's 0. And then you add the period, which we said was 6. Again, you're going to understand why in a second, why I didn't make it 7. Okay. Halfway between these would be what? 3 and then 1.5. Or if you are a fractional purist, you can write 3 halves. All right, and then this one would be 4.5. Good job. But it actually doesn't matter what those say because we have all of our answers right here. Where do we start?
30.
30. And then it goes down to what we say the minimum was? 18. And then back to the center line, 30. And then up to the maximum, which is 42, and then back to 30. Okay, yeah. I know everyone like hates story problems. I actually kind of like it though, because it helps you to understand the material better. Like things make more sense when there's a story attached. Okay. So now we're gonna have to be able to tell time here. All right. And I'm sometimes challenged with this, so we're gonna have to help each other out. When do the maximum and minimum percentages occur? Here's our maximum. It happens 4.5 days after midnight on Saturday. Okay. So let's label maximum. Now we have to count 4.5 days after midnight on Saturday. So let's see how that goes. Midnight on Saturday. So we're going to go midnight on Sunday, midnight on Monday, midnight on Tuesday. We skipped Wednesday. So midnight on Thursday, and then a half. So after midnight on Thursday, it would be noon on Friday.
That's a good thing.
We skipped Wednesdays. We got rid of Wednesdays. Okay. Now let's try and do the same thing with the minimum. Here's your minimum is the 18%. We have to go 1.5 days after midnight on Saturday. So midnight on Sunday, and then another half a day would be noon on Monday.
Yeah, that's why it's like the minimum and like the maximum.
All right, at time 3 days, which would be midnight Tuesday night, what is the percentage of pollution in the air? Well, look at your table. At 3 days, what's your percentage? 30%. Oh yeah, that's true. Good. I don't know. I should have thought that out ahead of time. But good thing we didn't get rid of Tuesday.
I wish it had none.
Yeah, right. So this is one of those gigantic wind turbines. Do you ever like go on a road trip and out on the highway, you see them like in the distance, those big things? Yeah. All right, so we've seen that before. So the height of, and they're big, all right, as you're about to see here. Yeah, they are really huge. The height of the blade of a wind turbine as it turns through an angle. Now, the units aren't written here for the angle, but they are going to be radians, right? Not touching degrees anymore. It's going to be radians. Your units for that, doesn't say it, but it's going to be radians, is given by this equation. And then height is measured in meters. We're going to be European and use metric for this one, right? So what is the period of the function and what does it mean? How would we find the period of the function? Good, 2 pi over 1.
Oh,
it would be 1 theta in there. So it would actually just be 2 pi. So how does your sentence start? It's the exact same as we did on the other side of the paper. It takes 2 pi radians. You need a number and you need units. It takes 2 pi radians to complete 1 cycle. That should make sense because 2 pi is what? Once around. So the wind turbine turns 1 full rotation is what happened there. All right, so that should logically make sense. All right, maximum and minimum, let's make our little picture. Where is our center line going to be? Look back at your equation. 40 is that center. Gonna go up and come back down. And so how would we get that maximum in there? You would take 40 and do what? Add your amplitude 8.5. So that would just be 48.5 meters. Pretty far up there. And your minimum, you're going to take that center line, that 40, and you're going to subtract 8.5. So 31.5. meters. Now, I think this part's actually cool. You have to use your imagination as this is spinning around. Explain what the value 40 means in the context of the problem. So what we're talking about is this like edge of the turbine going around and around and around. So if it's at the center line being 40, 40 represents what part of this object? Yeah, it's the height. Like this is your 40 meters. So yeah, like how would we want to say that? 40 is the height of the, what is the thing called? Turbine. All right, so 40 meters is the height of the turbine. I know you're having to write sentences in math class. It's horrible. Not like a whole essay or anything. It's okay. But yeah, that's the center. So this, you have to imagine, I don't have paper that will make this spin for you. I'm sorry. But you have to imagine this point here going around and around and around. So 40 is the center. It's going to go below that 40. It's going to go above that 40 and come back. So like if you're graphing the height, it's going to make a wave. Good. Yeah. Oh my gosh, that's the next question. Explain what the 8.5 means. So the 8.5 is the length of the blade. So 8.5 meters is the length of the blades. Again, they are huge. So let's do this. I'm going to pause the recording. I want you to try number 4 with your group. So I should hear you talking about it, and then I'll go over it and give the answers. We'll make sure we're all good. All right, I'll write up the letter A because I'm listening to you guys and it sounds like you kind of got through A. So I'll write that one up and you can check it.
We have to figure out how to. Between one and
Wouldn't it be 4.5?
No, because 9 is 0 is 4.
I'm getting 5 is in the middle.
It's not your board, Miss Cole.
Yeah, I wrote up that first one. If you guys can check it, just from listening to you, it sounded like it went okay though. I'm gonna write out the second one here.
Not bad. It's but your part is really you're not it's the beat, but all I hear here is like and I'm like up into the off.
Did you guys get 9 feet and 5 feet? All right, now it also asks, I'm gonna start going over it, guys. It also asks, when did they occur? So I'm gonna off to the side here, make my little table. This one was X and Y, so I'll just use X and Y. What is our phase shift? Because that's where you want to start in your table. Good, it went right 1. That's that X minus 1. So you're going to start at 1. And then you add the period, which is 8. So 1 plus 8 is 9. Halfway between those, it's 5. And then these all just end up being the odd numbers, right? Okay. Now, you can just look at your picture here. Where do we start? 7. And then it goes up to 9. Back to 7. Down to 5. Back to 7. All right. So when does your maximum of 9 feet occur? At 3 seconds. And then your minimum of 5 feet is at 7 seconds. As foreshadowing, do you see how the only heights you can get are 5, 7, and 9 for right now? In a couple of units, we have one more unit and then we'll get to solving the equations. I'm going to teach you how to get the ones in between. So say you wanted to do like 8 feet. I'm going to show you how to do that. So we will eventually get there. Yeah, go ahead. No, the only part that you really need to know is the amplitude. That's really the only distance. You don't need the other part for anything. Yeah, go ahead.
Isn't the answer to C
Hey, can you guys all stop talking while I listen to this question? Thank you.
7? Is it 7?
For this last one? Oh, I just didn't get there yet. All right, height at time 5 seconds. Yeah, so just look at your table at 5 seconds, 7 feet. Again, all I can ask you about right now is what's in this table. But again, moving forward, I could ask you about 1.3 seconds. Do you get what I'm saying? Like, I'm going to eventually teach you how to do that. We're just not there yet. So right now, it has to be one of the numbers in the table.